25, we're going to tell if the number is real, rational, irrational, integer, whole number, and then order from least to greatest. So I'm going to make a little chart. I've got negative square root of 12, negative 3.7, square root of 9, and 2.9. We're supposed to decide if they are real, rational, irrational, integer, or a whole number. I should probably use my line tool, but we get the idea. All right. I think the easiest thing to do is maybe start with the square root of 9. Think of that as just 3. 3, yeah, it's real. In fact, all the numbers that you deal with, they're going to be real. You don't deal with non-real numbers until Algebra 2. Is it rational? Can you write 3 as a fraction? You bet. 3 over 1. If it's rational, it can't be irrational. It is an integer. It's a counting number, and since it's positive, it's a whole number. 2.9, is it rational? Sure, it's 2 9/10. Any terminating decimal is always rational. If it's rational, it is not irrational. Is it an integer? Nope, it's a decimal, which means it can't be whole either. Negative 3.7 is kind of in the same boat. It's rational. It's a terminating decimal, but it's not an integer because it is a decimal, and therefore it can't be a whole number either. Negative square root of 12. The square root of 12 is not a perfect square. It's not one of those numbers that has an integer as a square root. And those are going to be examples of numbers that are irrational. It's going to be some crazy decimal that goes on forever, so therefore it's not an integer, it's not a whole number. If you're going to put them in order from least to greatest, I would suggest making them all decimals first. The square root of 9, that is 3. Negative square root of 12. Let's see, the square root of 12 is about 3.46. So this is going to be about negative 3.5 roughly. It's good enough for putting things in order from least to greatest. The biggest negative is negative 3.7. The next biggest negative is negative 3.5, which they gave us as negative square root of 12. And then we've got 2.9, and then we've got 3.